All right. Just going to kind of walk through the notes that we went through today for those of you that were missing. I'm going to try to do this kind of quickly. I don't want to take up your time, but if you have anything that you're not sure about, obviously go back and double check the notes. So first thing I'm going to do is I'm going to kind of identify what we were talking about today. What was the emphasis? So we focused in on what a parallelogram is. Okay. Now, what is a parallelogram? It's a polygon with two pairs of parallel sides. Okay, so as I look at this, I'm going to try to move that so you can see it better. Two pairs of parallel sides. So everything that we work on today is probably going to come back to that concept there. So the first thing I'm going to do is I'm going to go ahead and draw out a parallelogram. Now I'm going to label all the vertices. Okay. Now in doing this, I'm also going to draw a diagonal in here. And that's right, we are going to prove that the two triangles are congruent. So as you look at that, as you look at the, get that a little bit better, look at the two triangles, I'm going to go ahead and mark AC as congruent to AC by the reflexive property. And I'm also going to mark these alternate interior angles to be congruent as well because the lines are parallel to each other. So knowing this, that then tells me that triangle ABC is congruent to triangle CDA by angle side angle. Okay, so the triangles are congruent by angle side angle. How does that help me out with proving anything? Well, what we then would know is that AB and CD, those opposite sides, would be congruent. And we would know these opposite sides, BC and AD, would be congruent. Again, all that's by CPCTC. Okay? So, what have we just proven? Well, what I would do is I would go back to your piece of paper that I gave you yesterday that is going to allow you to, that I'm going to allow you to use on your tests. Okay? We filled out section 6.1, that horizontal box, yesterday. We're going to fill out section 6.2, and here's what I want you to put in that box. There are actually 3 theorems that I want us to focus in on, and all 3 theorems start like this. Okay? If a quadrilateral is a parallelogram, then, and all of this is true. Okay? So the first part is this. What we proved up there is that the opposite sides are congruent. So I'm going to put that down. Okay? Now the next 2 theorems I'm going to actually draw out and just label the sides to be parallel. Okay? And I'm going to pick an arbitrary number for this angle down here. Let's say I make this angle 80 degrees. Okay? If that angle is 80, this angle has to be 100 because the lines are parallel. Sorry, my hand gets in the way there. The lines are parallel. And these 2 angles we call consecutive interior or same side interior. So I'm going to go ahead and put down that that's 100 degrees. If it's hard to see what I'm talking about there, if I was to redraw those 2 lines, draw a transversal, here's your 80, here's your 100. Okay? So consecutive interior angles are supplementary. Same thing with these 2. These 2 have to be supplementary as well. So this is going to be 80 degrees. And these 2 are supplementary. So this one has to be 100 degrees. And again, these 2 are supplementary, so that makes it the other one 80 degrees. So what have we just proven? Well, we've proven 2 things. One, what do we see about the opposite angles? Well, they're going to be congruent. So I'm going to put down for number 2, opposite angles are congruent. Okay? And then what do we see about these consecutive angles? Well, those 2 are supplementary. These 2 are supplementary. these two are supplementary, and these two are supplementary. So I'm going to put down that consecutive angles are supplementary. Okay. All right, now for the last theorem that I wanted to cover today, what I'm going to do is I'm going to draw another parallelogram. Okay. I'm going to label those sides. Actually, you know what? I'll just label those two sides parallel. Okay. And I'm going to draw in both diagonals. 1, 2, and I'm going to label that point E. Okay. Now what I'm going to focus in on are these two triangles for right now. Okay. And I'm going to go ahead and say, hey, if this is a parallelogram, which I know it is, the opposite sides have to be congruent as well, not just parallel but congruent. Okay. So in looking at that, what other things can we mark congruent? Well, I hope that we can see, that the vertical angles are also going to be congruent. Okay. We can also go ahead and mark out that these alternate interior angles here and here would have to be congruent. So this would lead me to an understanding that the triangles are congruent by angle, angle, side. Angle, angle, side. So I'm going to do triangle ABE is congruent to triangle ABE CDE by angle, angle, side. Okay. Now, with that said, I then would know that BE and ED would have to be congruent. And they're in the same position right there. So BE is congruent to ED. Okay. We also would know that AE and EC would have to be congruent. Okay. Again, all of this is true by CP, CTC. Okay. Now, I'm going to go ahead and mark my picture, those segments congruent, with a different color because I wanted you to see something. Okay. I don't know if you can see that very well. The question I want you to consider is this: what are the diagonals doing to each other? And what you can see is that this diagonal here is cutting this diagonal in half. Both those parts are congruent. And this diagonal here is cutting this diagonal in half. Both these parts are congruent. So what is that? What are the diagonals doing to each other? Well, we can go ahead and say that the diagonals bisect each other. Okay, diagonals bisect each other. Now, keeping in line with this, I want to look at a couple more things, and that's this. The notes that I gave you the other day, we went over the first three already, but this one right here, if we didn't go over because I didn't feel like we needed to. If a parallelogram has one right angle, then it has four right angles. What I mean by that is this. If I go ahead and draw out a parallelogram, if I have one right angle right there, since these two are supplementary, that's got to be a right angle. If these two are supplementary, this has to be a right angle. These two are supplementary, this has to be a right angle. So I didn't feel like it was necessary to go over this one, but yeah, it is also true. And as you look on the back side, the last theorem, this one we already went over, this one we did not. If a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. So as I look at this, if I go back to this one right here, what we can see, these two were congruent. We already proved that. And if I go ahead and mark out the vertical angles there, you can tell that with side angle side, we have these two congruent as well. And so as a result, we have two pairs of congruent triangles inside the parallelogram. Okay? So what I want to do is just take a couple seconds and kind of go over some of the equations that you should come up with. Okay? We were told with one right angle, all the angles have to be right angles, or that the opposite angles are congruent. So if I know that this is 90, there's my equation for x. If I know consecutive angles are going to be supplementary, this is 90 already, this one has to be 90 as well to make 180. So 4y equals 90. Okay? Again, those are the two equations there. For number 2, the opposite angles are congruent. So I'm going to go ahead and say 6x equals 90. The opposite sides are congruent. I'm going to say 8y equals 88. Okay. For number 3, I'm going to say that the consecutive interior angles are going to be supplementary. So 6x plus 12x has to equal 180. Okay. Now if you solve for x, you're going to get 10. And you can do one of two things. I went ahead and plugged that 10 in right there. So 12 times 10 is 120. That's a 120 degree angle. And we know that these opposite angles have to be congruent. So 3y equals 120. And you're going to get y equal to 40. Okay? Now you could have also plugged the 10 in here and gotten 60. And then 60 plus 3y is equal to 180 and got the exact same answer. For numbers 4 and 5, we know that the alternate interior angles are congruent, so this is going to be 55 and this is going to be 60. And so you could have set up your equations, because both these are triangles, 2y plus 55 plus 60 equals 180. Same thing with the other one, 5x plus 60 plus 55 is equal to 180. Okay. Number 5, both pairs of opposite sides are congruent, so we know that 30x equals 150, and we know that 2y is equal to 72. Now, I can't solve this one until I solve for x over here, so if I plug in, if I divide by 30, I get 5. Now 2y equals 72 times 5. Well, that's a much more doable problem because I only have one variable there. Okay. As we look down at the bottom side of our paper, I know that the diagonals bisect each other. So 4y is equal to 8, and 3x is equal to 12. If the diagonals bisect each other, 2y equals 28, and 4x is also equal to 28, because if these two are congruent and these two are congruent, then these two have to be congruent by the transit property. Again, I don't know if I covered that up. If these two are congruent and these two are congruent, then these two have to be congruent by the transit property. So I'm going to say that 4x is also equal to 28. Number 3 here gave a lot of people some difficulty, and so what I'm going to do here is I'm going to mark the diagonals as bisecting each other. Okay? And what we should then see is this, that all 4 of these triangles are congruent by side, side, side. Side, 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 and side, side, side. Okay? That means that each of these interior angles right here are all going to be the same measure. If they're all going to be the same measure, they all have to be 90. 90, 90, 90 to make 360 degrees all the way around. So the equation for x, I would do something like this, 2x plus 60 plus 90 equals 180. And then for the other triangle, I know that the alternate interior angles are congruent, so I'm going to go ahead and do 4y plus 60 plus 90 equals 180. Now, I didn't tell you guys this when I originally passed this out, but the y value right here and the y value right here, you guys don't know how to do that yet, so there's not enough information for us to do those two values. But for the x value, since the diagonals bisect each other, I know that 3x equals 10 for number 4. For number 5, I can go ahead and do this, something like this, 90 plus 3x, because both those angles are congruent to each other, is equal to 180 degrees. Okay? Now, number 6 is actually the trickiest one. Makes you think a little bit, but here's what I want us to do. The diagonals bisect each other. So I'm going to go ahead and show this, that this is 4 and that this is y. Okay? And I'm also going to show that the opposite sides are congruent, so this side right here is 17. Now if I redraw this triangle right here, it's a little distorted, it's hard even to really picture what it's looking at, But here's what we're looking at here. We have an x here, 8 here, okay, hopefully that didn't go off for you, but an x here, an 8 here, because of the 4 and the 4, and then we have 17 here. Well, how do we go ahead and solve for x? Well, x squared plus 8 squared equals 17 squared. We're going to use the Pythagorean theorem because we know 2 of the 3 sides of the right triangle. Now, to figure out what y is going to be, if I solve for x, and that's going to end up being 15, to solve for y, if I redraw this triangle